Hi everyone, my name is Elena Pagnin. I am an assistant professor at Lund University, and today I will tell you a little something about the research that I'm doing here, which is about enhancing data authentication. Before I dive into some details, let me tell you why this matters to every one of us. We live in a digital era where almost everybody owns a digital device. Now, try to think how many times during the day you are maybe sending an email to a colleague of yours, or a message to a close friend, or even a picture or a selfie or some document. Now, every time we are sending some digital information to somebody, we are essentially doing one assumption. And the assumption is whatever information we are sending will be received precisely as we send it. In this example, we have Alice, who is sending a message to Bob, and the message is, "See you at 10 a.m." So Alice expects that Bob gets precisely this message. But what happens if, while the message is carried between Alice and Bob, we have a malicious attacker, in this case Eve, a hacker, that tampers with the message and changes some information in it? For instance, "See you at 11 a.m. instead of 10 a.m. Now you will say, well, it's not the end of the world, we will meet at a different time, but Alice doesn't know that. And even worse, if we're not talking about messages between two friends, but we're talking about your software updates or downloading a new app on your phone, if you're not checking the source of this, you don't know what code you are downloading on your smartphone or on your computer. Even more now with connected cars, IoT devices spread everywhere. What happens if somebody is changing the message that you're sending to your smart bulbs and turns on the light in your house for a whole day, or unlocks your car, or blocks your bike so that you cannot use it? So making sure that digital messages are integer, so they are not changed in transition, and they are actually sent by the person who is authorized to send them, it's very important. And this is the aim of digital signatures. Digital signature essentially try to achieve what standard handwritten signature do, and a little bit more. For instance, the first goal of an handwritten signature is to certify the source of the message we are sending. So if I sign at the end of a piece of paper, it means that this piece of paper comes from me. What digital signatures can do more than this is that they achieve a second goal, which is they can be used to guarantee that the message was not altered in transit. Well, if I just sign a note, somebody could alter a little bit my handwriting in the note and nobody would notice. But with digital signatures, we are able to detect that. The way we do it is not by handwriting the signature on a tablet, but instead we use algorithms. In particular, we'll have a signature generation algorithm that takes as input a secret key, so something that only the signer knows and owns, and produces a signature. And then we will have a signature verification algorithm that uses a public key that everybody holds, and everybody can use this public key, which here represents as a magnifying glass, to check that the signature is correct and is correct for this specific message. Or to say, no, the signature is not correct, I don't trust that this is coming from Elena, or I don't trust that this is precisely what Elena sent. Maybe it's changed in media res. So this is what the standard digital signatures do. What I do in my research is I try to go beyond these features and actually augment digital signature with additional properties. For the purpose of this talk, I will present two lines of work that I have. One is on multi-key homomorphic signatures, where I worked for a longer time, and one is on a signature with flexible verification, which is ongoing work at Lund University. So let's talk about multi-key homomorphic signatures. In this case, imagine the scenario where we have different users, different people that generate data, and they all upload their same data to a database. Then we have another user who just wants to query the database. For instance, maybe I want to know the average temperature in Lund during November and get an answer back. Now, if this data is not authenticated, there is nothing that prevents a malicious actor to jump into the database, change some bits, and then tell that actually we always have 30 degrees in November in Lund. What multi-key homomorphic signatures aim at doing is basically prevent anybody to alter the information that has been uploaded on the database and allow our user here, the green user, to make sure that the answer he gets is indeed being produced by the yellow user, the orange user, and the blue user, and that the answer he gets is precisely the average of the temperatures and not a number that maybe depends on something else, like the minimal temperature or the maximum temperature. So if we try to formalize it, the goal that multi-key homomorphic signatures aim to achieve is to certify the correctness of computations performed on outsourced database. Recently, me and a colleague of mine used a case of study to certify COVID-19 statistics. We used Spain, so the different regions of Spain uploaded their death rates and other healthcare data, and we just run it as a test bed to see how good our signature scheme is. Can we actually certify that whatever numbers we see in the web page comes from authentic data and not somebody putting numbers there? Now let's move into signature with flexible verification. So as we said before, we have a message and a signature and then a verification algorithm that checks this and returns a yes, the signature is correct, no, the signature is invalid. What we want to investigate with this work is what happens if, for whatever reason, we are stopping the signature verification in the middle. Maybe this could be a malicious attacker that prevents us from running the full verification algorithm, or simply our device is out of battery and we don't want to use the whole battery. We don't want to spend battery to finish the verification algorithm. If we just use standard digital signature, we are unable to get any useful information by a partial signature verification. So the whole idea of flexible verification is instead to be able to infer some useful information even from a partial signature verification. In particular, this means that even if we interrupt the running of the algorithm halfway through, we will be able to say that either the signature is wrong with 100% accuracy, or I have a confidence alpha that the signature is correct. And this alpha, of course, will be proportional to the number of steps that I'm doing in the verification, and for some of the construction that we have is actually increasing exponential. So it's we just need very few steps to come very, very close to be almost 100% sure that the signature is correct or not. So to conclude, I just want to say that many people have worked on digital signatures since almost 50 years from now. There are a lot of algorithms that are in use, and it's very easy to protect yourself from small hackers that try to tamper with your communication. And yeah, very soon it's also going to be efficient. It's also going to be easy to have a signature with additional properties, such as flexible verification or multi-key homomorphism. And I want to thank ELLIIT for making part of this research possible.
Thank you, Elena, for that presentation, and welcome to the studio.
Thanks.
That was both quite easy to understand and extremely difficult. Because, well, I didn't get the difference between the two. So you have to explain that for me once again. But first of all, from Italy?
Yes.
Elena?
Yes.
And where in Italy?
Padova. It's a city between Venice and Verona, so northeast.
Northeast coast,
yeah.
Okay. And how do you, well, you arrived, you came to Sweden. Research or love or both?
Well, it was mostly research, so I came here as a PhD student at Chalmers University, and I kind of love made me stay in Sweden and come back to Sweden after the postdoc and kind of try to root here. Okay, good.
And then you came to Lund.
Yes.
We are filming in Lund today, and you started your research. You took it with you from Chalmers, or you just start here from scratch?
Well, I mean, I have some research paths that are continuing. So from the PhD and then the postdoc, and now as an assistant professor, and there are also some new projects that are starting. But I joined during the pandemic. That was a bit of a unique experience to do, like move to a new city, move to a new workplace.
Well, it's strange for us all. But if you so when you grew up in Padua. Mm-hmm. Were you interested in these issues at that time?
No, actually. So in the high school, I took languages.
Okay.
So back then I could speak very fluently German, Spanish, Italian, and English.
Okay.
Now Spanish, Italian, and English stay. German is substituted by a bad version of Swedish, but we are getting there.
Well, you'll manage. So,
Yes.
and how did you make this shift then?
So it was when I started at the university, I realized that I really liked talking to people and knowing people, but I don't know if I wanted to make a career out of it. And then I started to study mathematics because I realized that was a skill I didn't develop that much during the high school.
Okay.
It was a tough 3 months, but afterwards, when I started to understand how to reason in mathematics, that's something I was never
just
taught
take
before.
3 months?
It took me 3 months. Around Christmas, I had like, but then this means that.
Okay, yeah.
And since then, it was just, okay, this is what I like. And after the bachelor, I was thinking, okay, I love mathematics, but I don't want to be in my ivory tower like any professor sitting there and disconnected to the world. What can I do with it? How can I use it to do something good for society? And that's when I discovered cryptography. That has a lot of mathematics behind, but you know, it's useful for making our digital life secure. So that was,
Yeah, great. And
perfect match.
But then you're talking a lot about signatures.
Yep.
And then you have the image of a handwriting.
Yes.
But it's not handwriting we're talking about, not at all.
No, it's bits, zeros and ones.
Yeah, but we use handwriting. We used to we wrote our signatures on different digital surfaces and stuff like that.
Yeah, on the tablet you can write it, but that's not a digital, like maybe people call it digital signature, but it's not generated by an algorithm. It's just your handwriting. It doesn't have the same properties as a digital signature algorithm.
Is this useful?
Well, I don't know from the loyal perspective, but I mean, it gives you something, but it's not the same properties that a digital signature algorithm gives you.
So when you talk about digital signatures, it's all like a bank ID.
Similar to bank ID, precisely. Okay. So you're going to have like some secret key, a PIN code that you put in, or maybe even like stored in a USB key, you know, those things, and then you press it into your computer and that signs a message. So the signature is not the same that you can copy paste to different PDFs, but it's going to be unique for every PDF.
Yeah.
And it's going to be a payload to the message.
And we have bank ID in Sweden. It's quite fascinating. It was the banks who really developed it, as I've learned to know. What are if you take from other countries, what do they have in Italy?
You just go and queue at the bank.
Yeah, you don't have a digital signature?
I don't think so. I think there have been some improvement, but they are years behind Sweden. So in Denmark, they have name ID, which is the same as bank ID, that I know. But for other countries, I don't know. I know Belgium is very much ahead with digital.
They don't have this system.
Not as well integrated and widely adopted as in Sweden, I would say.
Okay, and is it? And can you say bank ID, is it a good system or has it many weaknesses?
I haven't investigated it to give an informed answer to that question.
Okay, well, because and then you talked about the other where you have a couple of people. Can you just go with me, take me through that story once again? Why do you need that kind of system? Okay,
so suppose we are researchers in a lab and we are doing some experiments and then I'm uploading the results of my experiments in a database.
Yeah.
What if tomorrow somebody goes there and change my numbers? I wouldn't notice, and then a third researcher would use wrong numbers. So I upload my numbers with a signature saying Elena has produced these numbers during this specific lab experiment.
Yeah.
And then it comes to you and you produce your own signature for your specific thing. And a researcher in the other side of the world would like to combine our two experiments and say, oh, look, from this and that, if I put them together, I get these things. And if it does it without authentication, we don't know if it has used the corrected data. We don't know what kind of operation is done on our numbers.
Yeah.
So that's basically the aim.
So if that happens, will you two have to give your signature so this is correct, or? Yes,
but the signature is just a short payload that you add to the message. So it can be stored on the cloud and you don't need to interact at all.
Yeah.
So when I upload, I don't know, I get 300 as a measurement of something, like 150 for the blood pressure, then I can just add my signature that this was what I collected on a specific day and the specific value.
So and if you take it into within the ordinary life and the society, where will we use this?
Healthcare data.
Healthcare.
You want to make sure that it's your own blood pressure, or who has collected your blood pressure, or if they say that the average blood pressure of people that are 50 and above is this, you want to make sure, okay, but what data did you use? Is this the actual data? Or if we talk about COVID statistics, how can I be sure that the numbers that I see on the webpage are the correct one? I trust Google because I trust Google, but if I could have a signature that says, yeah, this is certified by the Swedish state or by Lund municipality, then I would be more,
And what would you say? Are we naive? Do we rely on all the stats and think, oh, this is 100% secure, or are we on the opposite side? No, you can't rely on anything. If you would look at the overall perspective, how naive are we?
Well, I think in Sweden, maybe people are more than naive. I would say you tend to trust others. Yeah. You don't have any reason. You cannot believe that someone else has some hidden reason to try to fool you. And I think, especially in the Nordic country, this works because the society is fairly honest. But if you go to other realities, like in Italy, just to mention one, since I can.
Just to mention one. Okay,
yeah,
Italy,
fake news, there are so many. So there it's really important to check the source of your data.
But isn't that in some way good that you don't have the of course I realize there's strengths in being having a high level of trust, but then of course you also can be fooled more easily. So what's a good combination of trust within the society and also being aware that it could be, I should check this?
Well, it doesn't harm to add the digital signature to whatever data you publish. Then it's up to the user if they want to check it or not. Like you can add a fake signature that won't verify that it's wrong, but if people don't check it, it's because they trust you. But if one person wants to check it and then say, hey, look, this is wrong, then this person can actually, say that's fake news instead of, it's an easy way to check the authenticity of data. So I would say just add signatures wherever you can, and then it's up to the user if they actually want to.
And how do I do that? I want to add signatures. Can I? When would I be able to say that? Actually, I think we should add signatures to this process. Where can I say that? I want to say that soon.
Yeah, well, you need an infrastructure. You need to teach a little bit people then how to verify signature. But actually, many of these things happen behind the scene in your computer. So often when you download a software, your computer is actually checking the authenticity of the source that is downloaded the software to, or especially an update to your phone, for instance, when you are upgrading to the new operating system. Yeah. So these things are happening behind the scenes without people noticing. So I think that's maybe the way to go. Let's try to make this more automatic. And then we can add these little payloads to the.
But since we need to rely, and since we are, how to say, the transparency of the system, don't we need to know where it happens? Because it will be automatically, you say. Yep. But isn't it good that we know actually what the process is, what's happening behind our...
It's very good, but again, then you need a couple of courses in computer, computer security. Yeah.
But I mean, we don't believe in facts, and we don't. Oh no, you can't say that's true. Blah blah. Isn't the way? How to help? Rely on facts and believe this is the truth, and being able to check things. Is this the way to help? Our society from antitrust?
Well, I would say prevent some fake news, because then you would say, okay, but you said there were 100 people at this manifestation, but if I check the website and all the data that has been certified there, I see that it doesn't add up to 100. Okay. So that's a way. Yeah. But it will require some work from the user perspective.
Yeah. When it comes to biometric, eye scanning, and how does that fit into these systems?
So that's also an authentication method, but it's not on data authentication. So you're not authenticating a message or a document. You're authenticating a person. It's more like person identification.
Yeah, but can't you? Because that I can easily understand. Okay, if they can see my blood vessels within the eye. Okay,
yeah.
And it's
but then it says that it's you. It's not necessary that you produces this message with the specific properties.
Yeah.
But maybe what you're saying is like trying to combine and use my biometrics as a secret key to generate a signature.
And on what kind? And can you tell me any other techniques? We have eye scanning. What are the other?
Fingerprints. Some people also try to do biometric authentication with gaits, so the way you walk.
Yeah.
Seems to be like a specific pattern, the veins in your hands.
Oh, here he comes. I see.
Facial recognition, Face ID, smile.
So what will we see in the future? Because we have the bank ID and we have the face recognition, the silly walks, and whatever it is.
I mean, shake your phone in a certain pattern.
Yeah. So what will be the standard, do you think?
Well, I see that like facial recognition is becoming more and more in use, especially with the unlocking smartphones and these kind of things. So I think we will find something that is easy to use, fairly secure, and user-friendly. Because if it's not user-friendly, like as you said, I will not connect a USB stick to my computer every time I need to send an email to certify that it was sent by me. So
when it comes to if you are very you're very worried about the development. The digitalization. No, I'm not secure in that system. Do you think we could be? Well, can we feel secure about that this will go in the right direction?
I think so. There are enough researchers around the world that are working and peer reviewing each other work to make it solid, and there are also, we are looking ahead what's happening and already creating algorithms that will withstand when quantum computers arrive.
Yeah.
So I think the researchers are really looking 20 years ahead and solving problems that will pop up there.
Are there any evil researchers on the other side?
Well, you call them hacker, right?
Okay. That's an evil researcher. So, and how much do we need the all nations coming together? Because, well, we have politics and we have other, things that matter. Do we need all countries on the planet to come on the same side and accept these systems, or will it work even if we don't? Even if it's not all participate in these agreements?
Well, I think it's way easier to implement something in a national level, and that's already complex enough. And I don't think the whole world is ready for that, because we have several third world countries that are not there yet with the digital technology we have.
Yeah.
So I would say it's more like nation by nation, and then cross-nation. There are actually European projects sponsored by the European Union precisely to allow cross-nation usage of data. So how do you, if I have, let's say that I did a vaccination in Italy and one in Sweden, how can I tell one country that I was vaccinated with this specific thing? Just to pick a COVID test, it has been a mess for some colleagues, friends of mine that did it. So it's like, it seems easy, right? We're all Europe, but some things like that could be maybe solved through authentication. And
since you know all the languages of the world and can speak with all the people around the world, if you compare, what are the strengths in Sweden, and where are the weaknesses? What should we develop here?
Are we allowed to talk about weaknesses in a politically correct way in Sweden?
Yeah, try.
Well, strengths, I would say honesty and trustworthiness that you have in the other. Simplicity, logon, like standards are there. Maybe on the weakness, maybe what you said, naive, like try to believe a bit without poking or probing that it's actually correct.
Yeah.
Sometimes maybe being also more straightforward with what you mean. That could increase and avoid, loops of trying.
I think that's you come up with the traditional things we say about Swedes. So I get you're right then.
I've been here for a while, so that's
I can certify that. So
thanks.
Correct, good. Very nice having you here, and thanks for the presentation.
Yeah.
And good luck with your research.
Thank you.
Thank you all for participating and watching this episode here from ELLIIT.